let's look at these examples of misleading graphs and try to figure out what might be wrong about these graphs that's causing them to mislead the reader. So let's zoom in on our first graph here. It's talking about the marks scored by 4 students in science this year, or talking about the grades. So the grades they got in science this year. And it shows the actual scores they got in science class on this axis, and it shows the names of the students on this axis. So one thing that you always want to look for in a bar graph that can be misleading, not always necessarily misleading, but definitely can be, is where the graph starts. Generally you want to start your graphs at 0, because that makes it clear that you're going from 0 to some number, and you can compare the amount of difference between them relative to a single starting point. This graph here starts at 93, meaning that the lowest possible on this graph is actually a pretty high number. So Mike here looks like he's got a very short bar on this graph and didn't do well in science class. But in fact, if you follow Mike over to the scores, Mike scored a 95% in science. So, and I don't know about you, but that sounds like a pretty good grade to me. So this graph is a little bit misleading because of the way it did the axis here. So what's wrong? You would write something like the y-axis does not start at 0. And an improved graph would be taking the same graph and just drawing a very quick sketch where we list the 4 students. And when you draw these graphs, the point is not to make them perfect, so you don't need to write out every single name completely, but to show the general idea of what's changing. So on your axis here, if you start at 0 and go to 100, have 50 in the middle, and you draw out these bars, you can see that Jimmy was at 99 and Jack at 98. So the first one goes to 99, just under 100. The next one goes to virtually the same spot, just a hair lower. Mike at 95 and Ashley at 96. And as you can tell here, these bars look like they're almost all the exact same length, and that's because in fact they almost are. The lowest score is a 95, the highest is a 99. They're all within 4% of each other, so it makes sense that all the graphs would actually, all the bars on the graph would look very similar. Let's go to our next one and try to figure out what is misleading here. We're going to look at our x or our y-axis, and it looks like it doesn't have the problem the last one had. It does in fact start at 0. It's evenly spaced, nothing to worry about there. Across here we have 1992, 94, 95, 97. I don't know about you, but last time I tried to count, that doesn't seem to make sense. It looks like we're missing a year here, and here, and here. And when you're missing years in a graph, it's hard to know what exactly was happening. It might be that those years had things that broke the pattern. So maybe their bars looked really weird and would ruin this nice pattern that seemed to be the case every single year otherwise. We just don't know. So when a graph is missing information like that, we might want to go ahead and say something along the lines that data is missing. In the improved graph, we might say impossible because we don't have the data. So on the what's wrong, make sure you explain that it's important to include data from each year, not just some years. If they did some kind of pattern like every 5th year, fine. But if they just randomly have gaps, that's a problem. Continuing on, we have this pie chart here. And one of the things that I notice when I look at this chart is that this chunk of the pie, or this chunk of the graph, takes up well over half the screen. But if you actually take a good look at that picture, it's clear that that section of the graph represents probably 20%. Whenever you tilt something or change the way it looks in order to make it appear larger or smaller than it actually is, that's going to be misleading to the reader. So when you say what's wrong, you're going to want to talk about something how what appears to be very large is not very large. And an improved graph is probably going to be something where you draw the same pie chart but flat. This next one has a similar challenge to it. This graph right here, what you'll notice is when this gets twice as tall, it also is going to get twice as wide. So this one right here is almost twice as tall, but it also makes it almost twice as wide. So in actuality, what we have here should be a little more than half of the 1980s box. But if we were to draw this out and make copies of this, we would see that it takes quite a few to fill it up. And although this isn't perfect here, you can see that it's a little bit, that 4 is a little too much because this part here on the edge is extra. But it takes probably at least 3 of the 1960 graph in order to fit inside the 1980 graph, but the 1980 graph is less than twice as tall, so it's growing at an unfair rate. Whenever you make your picture taller and wider, when it just should be getting taller, your eye is going to be tricked into thinking that it's grown a lot more than it really did. So that's a deceiving thing. Gun deaths in Florida. This graph is very interesting. This was actually published in a newspaper in order to make a point about certain gun laws that were passed. You can see here in 2005 that a certain law was passed called Stand Your Ground. The idea is that you're allowed to defend yourself with a firearm in that state, whereas previously you were not. And it looks like, based on this graph, that gun deaths actually dropped in the state shortly after that law was passed. But if you take a hard look at the graph, you'll notice on the side here what's actually going on. It's counting backwards. This graph is flipped upside down in order to deceive the reader into thinking that gun deaths went down after this law was passed, when in fact gun laws went from here, which is, you follow that across, probably somewhere a little over 500 gun deaths per year, to 2 years later maxing out around over 800 gun deaths per year. So that's getting close to doubling the number of gun deaths over a short period of time, or at least making a significant increase after that law was passed.